Here we go, guys. Welcome back to this video. Today we're going to talk about bypassing UAC. UAC stands for, the U stands for user, A for account, and C for control. So what is UAC anyway? The first thing to know about UAC, guys, is that UAC is a feature seen on only Windows operating systems. Okay, and it is a feature that forces all the processes running on the Windows operating system to start in low privileged mode. So what do we mean by that? Let's take an example. Let's say we have two users. The first user is user and the other one was admin. And let's say user wants to start Notepad. So let's see, we have Notepad. What happens here is that UAC forces Notepad to start in low privileged mode, meaning to start with what is called medium integrity level. So here, M for medium and I for integrity and L for level. So no matter what was the user, Notepad will start by default in medium integrity level. There is another level which is high integrity level. Now, high integrity level, here where UAC kicks in. So when user or admin starts Notepad, Notepad will start in medium integrity level so that all of the actions and the changes done by Notepad will be done in a low privileged mode, meaning Notepad cannot modify sensitive system files such as registry keys or files found under System 32. Therefore, Microsoft invented UAC. They assume that if user downloaded something from the internet and they are opening a virus, now, if the virus starts in a high privileged or high integrity mode, the virus will be able to change critical system files or will be able to change critical system files, critical registry keys. To protect the user and operating system, Microsoft has invented UAC so that regardless of the user here, user or admin, okay, every process they start will start in medium integrity level and will have limited access or limited scope in what changes it can do on the system. Now, you may have noticed that when you want to start a program, you have something called run as administrator. So run as administrator here is an exclusive option that allows you to run the program in high integrity level. So why you need that? Sometimes we need this in order to install a program that is not signed by Microsoft or to do a critical change on the operating system. So we choose run as admin here. So whether running the process as an admin or running it normally, okay, under the context of the current user or the current logged in user, UAC here kicks in so that by default the process will run as or will run in medium integrity level. Now, if you want to run the process in a high integrity level, you have to choose run as administrator. Now, you may have seen how to control the settings of user access control by going to control panel, selecting user accounts, and from here we click on change user account control settings. So we have the different settings of user account control. First, we have always notify. Always notify here will prompt for the user authorization, okay, when making changes to Windows settings or when a program tries to install applications or make changes to the computer. So here you always get the notification to authorize the action. Now here we have notify me only when apps try to make changes to my computer. So here we will get the prompt when a program tries to install applications or make changes. Administrators will not get this. Okay, so if you are logged in as an admin, as I am here, And if the UAC settings are set to notify me only when apps try to make changes to computer, the administrator will not get any prompt. And here we have notify me only when apps try to make changes to my computer, don't dim my desktop. Same as the above one, but will not run UAC on secure desktop. And the last one is to completely disable the UAC, which is not recommended. Now, if you disable UAC here, administrators on the system, they don't need to they don't need to use the option run as admin when they want to run the program in a high integrity or as a high integrity level. Meaning, they only need to double click the program and UAC here will not kick in, will not ask them for authorization. Do you want to perform this action? Yes or no. It's not going to show up if you disable UAC. So UAC can be completely disabled using this option, never notify. But again, it is not recommended to disable UAC unless you know what you're doing. So I'm gonna put this back. You see, that's the UAC here. It is just an authorization and confirmation to continue the action. Now, this type of warning will not show up if you are conducting the same action from the command line. Okay, so which means if you have got access to a machine as part of a pen test and you happen to compromise the machine using a partial session or a regular session from the command line, and you try to execute an action as administrator, this warning will not show up, meaning you will not be able to perform this action. Okay, so I'm gonna say yes. Now, one way to find out what kind of integrity level you have on the system, you can execute whoami/groups. Whoami/groups here shows us all the information we need. As you can see, the first entry here, mandatory label, medium mandatory level. Even though I am administrator on the system, still my token is medium mandatory level, which means if I want to run a program with the highest privileges, I have to go through the UAC or the user account control. For example, let's say I want to execute this program as administrator. I'm going to right click and select run as administrator. Selecting this will spawn a process of the program in a high privileged mode, meaning the program now has all sorts, actually unlimited access on the system. It can do whatever it wants. That's the ultimate objective of the attacker compromising a system. They want all the applications, all the backdoors, whatever they drop on the system to run in a high integrity level. So we run as administrator. See here, the UAC now kicks in. It's asking me to confirm the action. So if I say yes, this program now will have unlimited access to the system. It can do whatever it wants on the system, making changes, changing the registry keys. You know the drill. So the thing is, as I told you guys, this warning or the UAC warning here doesn't show up if you are doing the same thing from a partial session or the command line. AutoElevate is a configuration that you can enable on any application. Thing is, AutoElevate comes enabled by default on some of the applications found on Windows operating system. That's good news. For an application, some requirements need to be met so that AutoElevate comes pre-configured. If AutoElevate is pre-configured, meaning no need to go through the user account control, right? Meaning applications now can start and do whatever they want on the system. But we have to meet some requirements. The first one is the executable should be signed by Microsoft or signed by Windows. So signed or Windows signed, let's say. That's the first condition for an application to have AutoElevate pre-enabled or pre-configured. The executable should be in a trusted directory on Windows operating system. For example, trusted directories can be system root, system 32. That's a directory that's considered as a trusted directory. Another trusted directory is program files. So these directories are considered as trusted directories, which means if an application is found there, okay, it's gonna have AutoElevate enabled, pre-configured. Now, some applications you need to check whether AutoElevate is enabled or not, because some applications has AutoElevate pre-enabled, okay, in their manifest. We can check if an application has AutoElevate enabled using a tool from sysinternals. The tool's name is signature check. All I have to do is to run signature check, use the option -m, and the name of the executable file. It could be test.exe. Okay. Now, some examples of applications found on the Windows operating system. They come by default, they come installed by default and have AutoElevate enabled. We have the MMC, we have the package manager, and we have the Fodhelper. Now remember that every single one of these applications have actually a specific functionality found on Windows operating system. Remember that also these applications come by default. So if we want to bypass user access control, user account control, we will want to use one of these applications. We will want to manipulate the inner workings of these applications. So when we start one of them, it's gonna trigger an action of our choosing. In this video, we're gonna talk about Fodhelper. Now, Fodhelper is a tool that manages Windows optional features such as languages, applications installed by default, and other operating system characteristics. But how to do that? We will want to target what is called the file associations when we want to use Fodhelper to bypass UAC. So by default, guys, there is something called file associations on Windows operating system, meaning when you want to open a file, Windows will look for the appropriate program, okay, to open the target file. Windows will look in these two registry keys. One is machine level or system wide, another one is user specific. The priority goes to the user specific association. So if a program or if a file is configured to be opened, for example, by Google Chrome, and you have set that in the user specific association, it's going to take priority over the system-wide association. Now that's what we're going to do here to exploit Fodhelper. We're going to target the appropriate registry keys at the user level. So the key takeaway here is to find the target application's designated registry key that handles its file associations. So back here, we are targeting Fodhelper. We want to find out the registry key that handles the file associations of Fodhelper, meaning we want to see the registry key responsible for handling all sorts of files, all sorts of extensions that can be opened using Fodhelper. That's the key here. And this applies to every single application you want to target in order to bypass UAC. You have to find out the registry key of this, the registry key that handles the files associations. Luckily, since these are applications found by default in Windows operating system, we can find out the relevant registry key from Microsoft documentations. So for Fodhelper here, the relevant key can be found here. So on the user level, can be found under software classes, MS settings, shell, open, command. Having found the registry key that is responsible for handling the file associations for Fodhelper, we can follow certain steps to change the value here. So what happens when you open a file using Fodhelper, Windows will look at this registry key, and whatever it finds, it's going to use to open the file. So here, that's what we're going to do. We change the value found here, and we set a command to execute a reverse shell of our choosing. And following these steps, as we're going to do in the practical scenario, will give us the will enable us to bypass the user account control. So far we have seen how to bypass user account control using the AutoElevate. Now remember that this method only works if the user account control was set to any of these levels. If the user account control was set to always notify, this method is not going to work. Simply why? Because exploiting AutoElevate relies on conducting series of commands using the command line. And remember that the user account control do not show up when we work through the command line or through PowerShell. Therefore, if the user account control was set to always notify, if you are doing registry changes, okay, or privileged actions on the command line, the Windows operating system will ask for the authorization. And since UAC cannot show through the command line, these commands will not work. So what is another way of bypassing user account control if it was set on always notify? Let's take a look at these scheduled tasks, for example. Take a look at the Adobe Acrobat, for example, and we scroll down. We can see here in the security options, when running the task, the user use the following user account. We can take a look at what user is being used when the task runs. So here it is set on run only when user is logged on, which means it uses the logged on user, whether it is administrator or a regular user. And we can see this run with highest privileges. It is not enabled. So in order to bypass UAC when it is set to always notify, we have to choose a scheduled task where the run with highest privileges is enabled. As you can see, this one, for example, Microsoft Edge update. So in this one, we have run with highest privileges, and it is configured as the run whether user is logged on or not. Now this one also runs with highest privileges. So you have to make sure that the scheduled task we're going to target has this option enabled. Now there are two downsides to this method. The first one is not all the time you will have GUI access to the target machine. So if you have compromised the machine, I will assume most of the time it's going to be through a PowerShell session or a regular command line session. Therefore, you will not be able to check whether the scheduled task in question has run with highest privileges enabled. And it's going to be very hard to check these settings as well. That's one of the most important downsides to this method. The other downside was this method was only tested on the disk cleanup utility, which is not found here. We're gonna find this while we do the practical scenario of this video. But on my machine, it is not found. It was only proven for this method to work on the disk cleanup scheduled task. Now the last method of bypassing user account control is an automated method. So we can browse to this repository and we can find an automated tool that can be used to try different techniques of user account bypass. So if we go to binary, we can see no, not this one, source AKG. We compile this tool and we run it on Windows. Now the way to run this program, after we compile the executable, we can just run the executable and the corresponding number. Now every number here represents a UAC bypass technique. We can find all the numbers here. So keys. So 1 is going to try DLL hijack. 2, if you type 2, again, it is DLL hijack. It's very recommended to browse all these techniques, guys, if you want to use this tool to test for user account control bypass. If we look at 33 when scripting, let's look for Fodhelper. Yeah, see this one, number 33. It uses the Fodhelper we talked about. There is another one for disk cleanup. So this one here targets the disk cleanup utility through the scheduled task. Take a look at here. That's the target of this technique. Here we assume that somehow you have got access to a target machine and you want to see what kind of privileges you have got. So who am I /groups, and here we can check the integrity level we have been assigned. As you can see, it's medium integrity level or medium mandatory level. We want to switch this into a high integrity level, so we have unlimited access for all the scripts and the backdoors or the executables we can transfer to this machine. Okay, so let's go now through the basic steps. First, let's start a listener so remember, guys, that we discussed and mentioned that the registry key used by Fodhelper is here. So we're gonna first set the required values using this command. Okay, and then what we want to do, we want to set the command here to execute a reverse shell. Now the reverse shell will be executed using SOCAT. A copy of SOCAT can be found under tools. Remember that this is we are using the lab of this room from TryHackMe. So we go back here. Let's modify on the command a bit. So here we're going to include the IP address of the attacker. So gonna copy this. Okay. And here the port will be 4545. So I'm gonna copy this. Okay, next we need to create an empty value called delegate execute for the class association to take effect. So we're gonna just copy these two commands. So the listener is up and running. All we have to do is to execute the program, Fodhelper. So we're gonna navigate to cd c Windows, and we execute Fodhelper. And now we have received a session. Okay, fine. Let's now check the access rights. Who am I /groups. And we can see, guys, that the integrity level we are given now is high mandatory level. Okay, so this solves task 4. In task 4, we're required to what flag is returned by running the Fodhelper exploit. Okay, so we're gonna go back to the machine here, and from here we're gonna circle back to cd flags ls, they are, and we're going to execute this to get the flag. Since we have done everything correctly, we will be given the flag now, and this is the flag. Alright, the other method we talked about is through the scheduled tasks. So if we go to scheduled tasks and we look for disk cleanup, so this cleanup is here, and we can check that this cleanup is run as the logged on user. In addition to that, we have the run with highest privileges option enabled, which means this is a perfect candidate for UAC bypass. Another thing we have to take a look at is the actions. In the actions, we can see it uses environment variables, the Windows directory, and the system drive. So when using environment variables, we can replace the or we can manipulate the execution flow. So if we have a copy of SOCAT reverse shell or any sort of executable that will give you reverse shell, you can put a copy of this under the Windows directory environment variable, and this will make this cleanup execute your application instead of the cleanup utility here. Why? Because now the copied application will have a precedence over the intended application to be executed by the scheduled task. In this case, it is clean manager. And then we go to settings and we can see allow the task to be run on demand, which means we can execute the task ourselves. All right, so now you know what to do. We want to manipulate the environment variable here, Windows directory. To do that, we're gonna use the registry. So we go back here and we're gonna say reg add. Let me see if I have them on my machine. Always notify. I don't have this method on my notes, so I'm gonna have to use environment. Okay, /v, and the environment variable will be win directory. Okay, and then /d. And then here we put the command that we want to execute. So cmd /cc and the path to the reverse shell. And here we're gonna have to copy the IP address. Okay, now the port will be 4545. Execute named pipes and use REM. I'm going to put a space here after the REM to comment out every single entry that comes after what we have typed, or this value. So doing this now, okay, this was successful, and now we're gonna run the task scheduled. Oh, first we're gonna have to make sure the listener is up and running. The port is 454. Okay, and then we're gonna run the scheduled task. Run. Now the task we want to run is Microsoft. Let's go here and find out the task. So it is silent cleanup. it's essential to know the name of the task because you can use it in the command. This is not good. Come on, clean up. Okay, let's see here. Now we have received another session. Again, we're going to check the integrity level. And see, guys, we have successfully bypassed the user account control. Now the next thing you want is to grab a copy of the flag. So we're going to head to C flags. And we're going to execute the disk cleanup. And that's your flag for this task. Since we have too many methods to bypass user account control, it makes sense to look for an automated method to do all the work instead of manually looking for ways and wasting your time. If there's an automated method, it's going to make your life easier. So there is a tool, as I told you guys at the very beginning. You can compile this tool. Luckily for us, the tool was compiled by the author of the challenge. You can find it under tools. And this is the executable. All you have to do is to supply the executable name and the technique name to try. Okay, so C, CDC, tools. We have the tool name here. So we're gonna use the tool name and now supply the number. So first we're gonna have to visit the documentation of the tool to choose a method to try. Okay. And these are the keys. So remember, guys, that we have tried the disk cleanup and the Fodhelper to bypass user account control, and both methods work. So it makes sense now to try these methods using the automated tool, see what it comes out. So we're gonna search for them, Fod. So it's key number 33. So we're gonna type 33 here. A quick CMD has popped up and now disappeared. It means it didn't work. We're gonna try the one with 70. Oh, so now as you can see, guys, we have a new pop-up with the new CMD session. Who am I? /groups. And it is with high mandatory level, high integrity level. This means you have successfully bypassed user account control. Now let's try the other method. Disk cleanup. It is key number 34. So number 34. And it worked. Who am I? And it is high mandatory level. Okay, guys, so that was it for this video. I'm gonna see you later.